So, hi everybody, it's Lorenzo here. Welcome to to the third of our small group coaching with Wattics webinars. I see there are already 6 people in online, and yeah, for some of you it's morning, so good morning. For example, to Carlos from Costa Rica, and I would say let's wait just for another couple of minutes just to see if somebody else tunes in, and then we can start with the actual webinar. So in the meantime, yeah, welcome to you, and thank you for attending the webinar. This time the webinar will be about some of our analytics tool. So last time we focused on the monitoring tools, so the breakdown tab and the raw data tab. This time we will cover some, not all of them, because for example, the MMV tool will have a dedicated webinar because that there is something more to say about it. But we will cover some of our analytics tool, which will be the activity map together with the operation analyzer, and we will spend also some time in the action tracker. I know the action tracker wasn't not in schedule, but I thought it would be nice to spend some time in it as well, since it wouldn't have been covered by other webinars, and I think it's an interesting tool that can deliver some results. I know many of you already do know these tools, and so if you have any doubt or any question while I will present these tools, so maybe something that happened to you when using these tools, well, feel free to stop me and to put some questions. And with the same logic, I would say, since many of you already used it, if you have some interesting use cases or something that you would like to share, some best practices or whatever that you may have in mind related to these 3 tools, yeah, well, it would be very nice from you to share it with other people, because you know, there are many ways to use our tools, and every time that I have a customer success meeting, I get to know how people work, and it happens often that people just that comes up with a very interesting use case from a tool that I never heard of before, and it is maybe a very clever way to use a tool. So if you have something to share, feel free to raise your hand, to take the speech, and to share with others your knowledge, because the goal of these webinars is also to share to one another what we learned in using the dashboard. So that would be great from you. So I think now it's time to start, because otherwise we would go longer than half an hour, and maybe some of you have some meeting scheduled right after this webinar. So okay, welcome to the webinar, as I said before. To welcome also to people that joined in the meantime. And as I already mentioned, we will today we will speak about the activity map and operation analyzer, and then we will spend a little time also on the action tracker. Okay, so before we go into the analysis of this tool, let me introduce you a demo site that we developed just for the sake of this webinar and for a workshop that we had in Dublin last month. Data are coming from an actual plant, but they have been anonymized for privacy's sake. I decided to call it the Pasta Factory in honor of my Italian heritage, and in it there is just a site which is called the production plant. In this production plant there are 2 meters. One that groups all the appliances related to the admin building, and for which we have just a couple of months of data related to the consumption, and one is related to the production plant. So the building, let's say, in which all the production takes place. For both of them, we have some submeters. So for the admin site, for the admin building, we have a meter that is monitoring the HVAC panel. So these are ventilation units, fan coils, chillers, and so on. And another that is monitoring the offices. So this could be plugs, lights, for example, a fridge that may be in a snack area, and servers, and so on. While in the production area, we have some more specific appliances that this plant uses for processing the food. On top of that, we also uploaded a KPI. So with the same logic that I showed you in last time webinar. So using the data tab down here and uploading a CSV file. If some of you are wondering how we did it, my advice would be to check the record of the webinar that is available in our website in the webinar section that you can find in the media tab in the homepage of the website. So here, this KPI is basically providing information about the output of this plant. So what can we see here is that the production takes place just during the weekdays, and so no output is delivered during the weekends. So this makes us think that the energy consumption during the weekends should be lower, if not zero, compared to the weekdays. And another thing, another very interesting information that we need to know before we start having a look at the activity maps is that this plant, and so the people that kindly provided us this data, provided us also information about opening time for the plant. So we do know that during the weekdays, people are working from 6 a.m. to 9 p.m. and on Saturdays from 6 a.m. to 1 p.m. And this is a very valuable information, because now that I'm checking the activity map, I can check how this production and how the consumption during the month was calculated. So here is what the tool looks like. So it's basically a heat map. So the logic is that the darker is the color of the slot, the higher is the consumption, and every box represents the consumption in half an hour. For example, here in the first day of the month, from midnight to half past midnight. So what can we do with this tool is, well, first of all, to check if we can find some patterns in the energy consumption registered by Ammeter. And then what can we do is to check if the energy consumption is in line with, for example, working days, is in line with opening time, is in line to the production data that we have. So let's just start with a few, having a look at how this data look like, and then we can see where can we find some valuable information. So here is the HVAC. We know that people are starting to work at 6 a.m. So more or less, this is a pattern that we are expecting. So the consumption is high during the weekdays, at starting from a little before the time that people get in the office, so that the air is so that it's cold enough for people to work, or in this case the atmosphere is warmer, and so people can find a comfortable environment when getting in the office. And with the same logic, it gets switched off, in this case a little bit later than expected, because people are leaving the office at 9 p.m. But there is always those guy that stays for longer because they have some work to do. So I would say this is a consumption that is in line with what we expected. what happens if we take a look at the offices is that, okay, we expect a baseline consumption because, as I mentioned before, there may be servers, that may be fridges, that may be something that we don't want to switch off during the night. But here, the energy consumption is still high, also during the night. So there is something that gets switched on and off during the night. So it's likely that that some lightings have been left switched on, or that something is working in a way that we don't want it. So there is room for some wastage there. So this is a meter that we want to keep an eye on. As for the production, I would say, well, here it's a bit different because we don't know how the actual workflow looks like. So I did the work myself, and I know that the cook line is something that is expected to be switched on it's something that is working just when people are there, because for security reason it would be not so safe to leave ovens switched on during the night. And so here actually there is nothing. The ovens should be not working during the night. So here, as you can see, the consumption is very high also when people are not there. So here, this is another meter that we want to keep monitored. So what can we do here with both of these meters is to go to the operation analyzer, and we can use the data that we gathered from the activity map to go into further analysis. So let's start from the admin building and let's take a look at the offices. So we do know that people are in the office between certain hours. So what can we do here is we have this set of green boxes up here. When this tool works that every time we have one of these boxes is green, it means that the related box in the activity map is when one is green, it's the consumption is as it is. So let's think of it as an automated switch. Every time that the box is green, then it means that the switch is on. So the consumption is to be considered as it is. Every time that the box is gray, then we are sort of switching off the appliance. So in this case, we don't want any consumption to be considered during Sundays. With the same logic, we don't want any consumption, let's say, before 6 a.m. for all days. We don't want any consumption after 10 p.m. Okay. And we want everything to be switched off after, let's say, 2 p.m. during Saturdays. So I will untick, let's say, all these boxes, and this is this is the time, so the timetable for our plant in which we want we actually think of having the consumption. So what can we do here is to save this new schedule, and the system will evaluate the savings in terms of values, so in terms of energy, or in terms of cost. And what we see here is, let's think in terms of cost, because that is actually the goal, to save some money. So what can we see here is, well, at first we have a datum about the total yearly cost. So this is what we had before rescheduling the consumption. So if all the boxes were green, then our yearly cost, in this case, is just 2 months, but the system considers it as a yearly, because this is, if you have a year worth of data, then it would think in terms of a year, because it's easier to calculate the payback periods and so on. In this case, we have just a month, so the yearly cost for these 2 months would be this 1,500 pounds in this case, because this pasta factory is in England. And as for the operation costs, it refers to the green boxes that we have, to the actual time in which we want the consumption to take place. So here, this is the consumption that is actually on schedule, and it's 1,077 pounds. As for the wastage cost, this is the money that we are spending for energy, that is consumed outside the expected times. So during the night, during Sundays, and during and early in the morning. And we can see here that it is up to 30% of money to be saved just in 2 months when by using this different workflow. I said up to because as I mentioned before, there may be some servers, there may be some fridges, there may be something that we don't want to be switched off. But here, what can we do is to go back to our customer and tell him, look, here there is room for improvements, because I understand that something, is likely to be switched on, but 30% of the consumption during the night is way above what I expect for just some servers or just some fridges that are working overnight. So here, this is something that we can use to go back to our customer and put in some questions and trying to figure out where can we actually improve our customer workflow. With the same logic, let's take a look at the cook lines. So of course, again, we don't want them to be switched on Sundays. We don't want them to be switched on, let's say, up until 4 a.m. because maybe some ovens take some time to warm up. So maybe by using a timer that we can have them switched on before people are getting in the office, or maybe when just a few people are there for maintenance reasons. And with the same logic, let's shut it down around 10 p.m. just to make sure that the ovens are not working when nobody is there attending. So once we save the schedule, again, we have the same information. So again, it's likely that, okay, I missed the Saturday. So let's change the schedule again so we can save more money, the 0.1% more money. Okay, and again, what we see here is that there is room for improvement. So it's likely that that maybe our customer can tell us that these appliances need to be cleaned overnight. So maybe sometimes in the week it's possible that the oven still needs to have some power consumption because it needs to clean up itself, or for whatever reason. But here we have a datum gathered from actual energy consumption that we can use for getting back to our customers, putting some more questions and getting to know more on how we can actually save money for the customer. Okay, so I think I covered the activity map and operation analyzer. Needless to say, there is plenty of use cases for it. I would be very glad if some of you would share it. Before you put some question, I would go on with the action tracker. So I finish my presentation, and then there is room, there is time for you to put some question and to share your stories. So the action tracker I like to describe it as a light version of the MMV tool. The MMV tool will have a dedicated webinar because it's a very complicated tool in terms of the amount of information that we need to provide, but it's actually a very simple way to measure and verify. That's why it's called MMV, actually, to measure and verify the results delivered by an energy conservation measure. This action tracker, instead, is something very simple and quick that can be used to check for the same reasons the effectiveness of an energy conservation measure. The difference between the two, I will show you how it works, and then then you will understand why this is very quick and why this can be very useful for you to deliver results. So here there are no actions in this pasta factory organization, because as I mentioned before, this is just a demo site that we use for testing reasons. So setting up a new action is as easy as providing free information, as you can see here. So a name, the date in which this energy conservation measure gets implemented, a brief description in case you have a lot of actions implemented and you want to you want to make sure that you don't confuse them. And you can, as last time I showed you, there is a tick box here to have this energy conservation measure shared with people that have access to this organization and to the action tracker as well. Because as you know, admins can prevent people to see certain tools in case they don't want to. So to show you how it works, I would go back to the food corp. Here there are many cards that people uploaded. This is a site that you all have in your dashboard. So if you choose to make it public, there it goes. So I will see it and everybody will be able to see it. I would pick this variable speed drive installation, and I will. And here is how the tool actually looks like. So what it does is it picks the date that we provided in which we implemented the action, and it calculates the energy consumption before and after that the implementation of that action. It's 15 days before and 15 days after. And what it does is it calculates the daily average cost related to energy, of course, for that site, in this case for the whole organization, between the 2 days. So here is the daily average cost from the 17th of November 2014 to the 1st of December 2014, and this is the daily average cost from the 1st of December to the 15th of December 2014. So the big difference, I would say, between this tool and the MMV is that here we cannot relate the energy conservation measure to anything other than the date in which it gets implemented. In this case, the installation of a variable speed drive, which is the exact same project that we have in the MMV tool, it's not a very good example to describe this, a very good use case for this tool, because it's likely that the installation of a variable speed drive can deliver different results basing on the production, the output production of the plant. So it could be that this 7% savings is related also to a decrease in the production. So we have no way to double check if this information are good. But there are actually some very interesting use cases. And there is one that comes to my mind because I didn't expect something like, this way of using this tool. And it was actually to check how did the energy consumption increase. And the customer, I remember, it was very happy to see an increase, because that case was that there was a retail store that this customer basically used this tool to check how would have the energy cost increased if he switched on the HVAC overnight when nobody was there in the retail store that he was monitoring. And when he found out that the increase in the energy cost was about 15 euros, which is around $15 for who is not familiar with euros, per day, he was very happy because he worked for a retail store in China, and in China there is the air pollution is a very difficult thing. It is a topic that is very important down there, because if you leave your HVAC switched off during the night, as he told us, then the air can get in from the outside due to the differential pressure, and there is the air inside can become polluted. So when people opened the store in the morning, they experienced a headache, they felt bad, and so they needed to find a way to recover the situation. So the customer proposed to leave the HVAC switched on in the meantime, while waiting for some air purifier tools to be delivered to that store. And when he found out that the increase on cost was very low, then he decided actually not to buy this air purifier, because the daily cost the increase in the costs in using something that actually already delivered the results was didn't justify buying an appliance that would have cost thousands of euros, I would say, even though it was in yen or something. And so he decided to take an action, and he used this tool to verify how higher the energy bill would have been at the end of the month. So this is how it works. These are the tools that I wanted to show you today. So if you have some question, or if you want to share something, I think we have 5 to 10 minutes to have a chat about this. If you have some doubts or whatever, so feel free to raise your hand or to ask some questions. I see. I don't see many many questions. So yeah, I have another interesting use case to tell you about this. This one I found it particularly funny, actually, and it was a school that was using I mean, was monitoring the results delivered by an energy conservation measure. The energy conservation measure actually was something very simple, and I was like, really? There is a tool that can monitor the results of such an action? And the action that they took was telling people to switch off the line when not needed. So basically, they run a sort of campaign to teach these students about potential savings in terms of, and the benefits that the environment could have if we save if we save energy on our day-to-day life. And what they did was to use this tool to monitor if people were actually taking action. So if the daily average cost related to energy would have decreased, then that would have meant that people were actually switching off the lights, and so that they had learned how to use this tool. And what they did was to share the screen in the same way that I'm doing in a monitor in the hall of the school. And once they found out, I mean, once they started showing that the energy consumption, so in terms of cost, but I mean, at the end of the day, it's the same, because there is a direct correlation between the two. Once they started showing people that that the energy consumption was decreasing, people were, I mean, more involved in the thing, and they realized that the energy consumption was decreasing and decreasing every time, at the point that people were switching off the light even though they needed it. So I mean, the point of this use case is that there are many ways to use this tool, and that many ways that in which this tool can help you. And so in this case, well, there would be no need in using a very particular, a very peculiar tool such as the MMV tool that I will show you next time to figure out how much money are we saving when telling people to switch off the light. But this tool allows us to do it very quickly, and can deliver some results even when thinking of when analyzing, when taking care of this very strange very strange energy conservation measure. So I would say that that's it. It's we covered the all the time that we had at our disposal. If some question, oh, just a sec. I see. Okay, I see there is a use case from Carlos. Um, oh, okay. Yeah, it says that they use this tool to check how much would have the cost changed if they moved the energy consumption from day to night, since they had a different tariff, using an ice bank in order to have cold water during the day. This is very interesting, actually. So another thing is that at the end, due to the other production and operation issues, the cost increased about 5%. So yeah, I mean, it's not that every time the energy conservation measure must deliver a result. The point is also to check if it works. So if people if there is an increase in the consumption, that we get to know that that's not the way to go, and this is still a result, because if we didn't have a way to double check, then we may go on and we may keep on wasting energy, hoping that the energy conservation measure at some point deliver a result. And it sometimes is also good to get to know that we are going in the wrong direction, and so that there is I mean, learning a lesson is still a good result. So I think that we have no time left. I will let you go to your business, and if you have some question to put now, just feel free to email me. My email is lorenzo.casna@wattics.com, and so just feel free to put some question, and I'll be happy to help. So see you next time on next Thursday with the next webinar, and have a good day. Bye bye.